It's actually easy to underestimate the importance of some classes. Alright, so this particular topic today is not something that I would have ordinarily done, except that after assessing some students and I began to realize that, or I begin to realize that might have to put something in place in order to aid students' understanding of economics generally. And because in economics, you cannot do without models and graphs. So models, graphs, equations, and so on and so on. That is why mathematics is usually a requirement for any student that is studying economics. So because we're dealing with graphs a lot and models a lot, is it not important for us to really have a class that deals with this to a reasonable extent? Alright, to at least make students have a good foundation of graphs and so many things that they'll be going through in the future during the course of their study. So that brings us to today's topic, which is models and graphs. Models and graphs. By the way, welcome to Economics YouTube channel. So I got it. Okay, so what is a model? What is a model? I'm going to leave that out because what we are dealing with is economics. So I'd rather say, what is an economic model? Alright, so an economic model is a simplified description of reality that shows the relationship between variables and how some variables that are called independent variables influence or determine the outcome of another variable, and that variable is a dependent variable. Okay, let me go over that again. An economic model is a simplified description of reality that shows the relationship between variables and how some variables, that is the independent variables, influence or determine the outcome of another variable, which is called the dependent variable. So before I kind of explain this, okay, let me just explain it. So when we say an economic model is a simplified description of reality, we have like a phenomenon that we are trying to talk about, and there are so many factors that can influence the result of that phenomenon, and that is why I have a demand model on the board, which simply states that the quantity demanded of commodity X is a function of its price. In fact, let me just start from there. So we are saying that before this, let me just start from. So we are saying that Q dx is a function of price of the product. So we are saying that the quantity demanded of the X is a function of its price. Alright, so expanding that, we then have this where Q dx is A minus BPX. Now the thing is that this model is already simplified because we are looking at the effect of price. So price here is the independent variable. It can assume different values. Okay, the influence of price on the quantity demanded of this commodity. The influence of price on the quantity demanded of this commodity. So price is the independent variable and quantity demanded is the dependent variable. Why is that so? The value of quantity demanded depends on what happens to price. Okay, if by now you already know the law of demand that states that an increase in price will lead to a reduction in quantity demanded, all that is being equal and vice versa. Alright, so that is then that price goes first before the quantity demanded begins to react to that. So this is the independent variable and this is the dependent variable. So Q dx is a function of A. Now what I'm trying to drive at is that this is already very simplified because there are so many variables, there could be so many variables that will be influencing the quantity demanded of this product. And one is the price of this product itself. Another is the price of a related product, which could be a substitute or a complement. Alright, and third could be the religion of the populace of that particular place. Okay, for example, you expect that in a country or in a place where Christianity is taking ground, that Bibles are going to be sold. Alright, that people start to buy and sell Bibles and so on and so forth. So that's like a function of religion. Okay, and if you are a Muslim, towards the Eid al-Fitr festival now, alright, you then see a lot of Muslim families buying rams for the festival and so on and so forth. The sale of the demand for rams begin to increase at that particular point. So that is telling that that's a function of the demand for ram at that particular period is a function of a religious activity. So it could be a part. Now, weather could also be a part. If this product were, let's say, umbrella, it doesn't really matter if the price of umbrella is small. If the weather is not so shiny that people need to cover themselves with umbrellas, or if the weather is not so rainy that people need to use umbrellas while going out. Alright, so these are factors. So we also talk about the taste of the consumer, the income of the consumer. In fact, we are looking at personal income taxes, because that would influence the disposable income that the consumer has, and then that will affect his budget for this commodity. So you have that, and you have lots and lots of factors that are going to be influencing the quantity demanded of this particular product. But this model has simplified that. Alright, to be quantity demanded being a function of the price of the product alone. So that's already telling that this has been simplified. So this is a simplified version of reality. You have so many other variables that will be working simultaneously in influencing the quantity demanded of this product. But a model cannot bring in, usually a model cannot bring in all of these variables together. So the model builder, then having a notion in mind, there's something that the model builder wants to see, alright, which is the interest of price of quantity demanded. Okay, so it then builds the model to reflect that, and then assumes that other variables are kind of constant, so that it will be able to focus on the independent variable and dependent variable that it's looking at. Now, a variable would have more than one independent variable. So I want you to understand that you could have more than one independent variable. The quantity demanded of a product could be a reflection of its price, taste of the consumer, and then income of the consumer. So you could have, instead of having just P, you're having Y plus maybe plus C, Y, then you could be having taste as well. Alright, so this is going to expand. But then, this might be minus, then plus, let's say, CT, where it is representing taste, and then maybe a function of income. Alright, so you might have maybe alpha income, where we represent income. Alright, so it could be like that. It could be pretty long. Models are not that simple. It could be pretty long. But in all, what we're trying to say is that it is not looking at every phenomenon, every influence, okay, that is being had on the dependent variable. No, you can't just analyze everything. You understand? You can't analyze everything. So it is a simplified version of reality. Some textbooks will see, or some materials say, it's an abstraction of real life. Okay, which is true. It's an abstraction. It's just looking at the part of something, and models assume other things being constant, so that you need to focus on what you want to focus on. But other things usually are not constant. The taste of the consumer in this situation may not be constant. The income of the consumer may change. Alright, there's a time for religious activity, there's a time for no religious activity. So that one also varies. Alright, personal income taxes could rise or fall. That one is different. The weather changes. Alright. Okay, so these are, but then we kind of assume that all other factors, so there's a way economists and mathematicians do the estimation and everything, and then give a value for other variables. Now that is where the constant comes in, this constant A. Now constant A, look, the impact of this parameter is that when the independent variable in this model, which is price, when the independent variable assumes a value of 0, okay, the quantity demanded of this product will not fall to 0. It is going to be the value of A. So now let's say that quantity demanded is equal to, let's say 5. Okay, let me write that somewhere. QDX, after estimation, that's the problem of econometricians, mathematicians, and what have you. So we don't bother ourselves with that now. Until maybe a third year at the university. So let's say you have 50 minus 2. You have 50 minus 2px, for example. So this is telling you that if the price was 0, right? If the price was 0, you're having QDX equals 50 minus 2, 0 against 0, and then the quantity demanded of this product will be 50. So if the price of this product happens to be 0, the quantity demanded of the product is going to be 50. Alright, so this is just trying to tell us that even if the price was 0, there are other things that will make the demand of this product not fall to 0. So it could be the taste, people of the product, it could be the income. So it's going to be the interworkings of those variables that are not included in this model, that are not explicitly stated in this model. Alright, so when we say price is 0, if the price of 0, if the price is fall to 0, there are other variables not in this model that will result into the quantity demanded of the product being 50. Alright, so that's it. Now there's also another importance of this constant parameter, okay, which is this A. It tells us the intercept of the graph of the line. Okay, if we were to plot a line that shows the relationship between variables on a graph, the constant term here is going to tell us the intercept. So that tells us what a graph is. What is a graph? A graph is a diagrammatic representation of the interrelationship that exists among variables. Alright, so you have this, you have that on the board already. A graph is a diagrammatic representation of the relationship between variables. Okay, so there are different types of graphs, you know, but let's just make things simple by sketching stuff on the Cartesian plane. Okay, so if I were to something I want to mention, I've spoken about parameters. Now, when these parameters assume values, they become coefficients. Alright, so if A changes to 5 now, so that means the coefficient of price is going to be 5. Alright, so if A that has become 50 is more or less a constant parameter, Alright, so that's about parameters, variables, and what have you. Now there is I've spoken about the constant term telling us how variables not included in the model, how they influence the dependent variable. And I've also mentioned that it also helps us to determine the intercept of the graph. If we were to plot a line or a curve or whatever, it shows us the intercepts that exist on the graph from the model that we have. Now, how about the other parameter that is here, as it's just close, that stands beside the independent variable. So that parameter is the slope of whatever line that we eventually draw, or whatever, if it's a curve or something. So that parameter is going to represent the slope of the line. Alright, so the parameter represents the slope of the line. It also tells us one thing. It also tells us to what extent the dependent variable will change if the independent variable changes by a particular amount. And that is where we incorporate our simple, calculus, our differentiation. So we introduce, we say we differentiate. So since QDX is this, so we can easily say that the change in QDX, the QDX, alright, the PX, so we are differentiating the dependent variable with respect to the independent variable. It's going to be, because this one is a constant, it's going to give us -2. This becomes 1. Alright, so I believe by now you understand the basic calculus. And if you don't understand this in subsequent classes, you would understand it. It's very, very simple. Now from here, you can easily say that the QDX is equal to -2 the PX. Or some rules could be, instead of writing D, could be a triangle. Everything is just talking about change in. Alright, so whether you have D or whatever, or this triangle is just talking about changing that -2, then changing PX. Okay, so just trying to tell us the importance of this -2 here. Now, so if let's say the price of this product changes by 10, so let's say it rises from 10 to 20, right? Right, from 10 to 20. To what extent is it going to affect the quantity demanded of this product? Other things being equal, alright, that is going to be, we have change in QDX will be equal to -2. Now, what's the change in PX? The change in PX is 10. So PX goes from, price of X goes from 10 to 20. So the change here is just 20 minus 10. Alright, so the QDX will be what? Equals -2 times this -20. So we are expecting that our quantity demanded of this product will fall by 20. That's why you have minus. We fall by 20, other things being equal. So these things are not difficult things. At all. So from there, let us then move to, let's see, there's something that I have, that I have not included. Okay, so let us just move to the sketching of our graphs. Now let's say that we want to use this function to sketch a graph. Okay, let me just divide this to sketch a demand curve. Now, what I want you to know from here is that in the conventional demand curve, we have price, because whatever you, let me sketch this. So this is the x-axis, which is talking about the independent variable, and this is the y-axis, where you are going to be putting your dependent variable. So where the value of y depends on whatever value that x takes. Now, the thing here is that the dependent variable here is Q, right? So Q is supposed to be here. Okay, Q dx is meant to be here, and the dependent variable is Px, price of X, which is meant to be here. But the in conventional demand graphs or demand curve, you have the price here, and then you have the quantity demanded here. So in that case, this would have been resolved to give us, so you have Qdx equals 50 minus 2px. Then 2px will be equal to 50 minus q dx. So you divide both sides by 2. Okay? So you have px being equal to 25 minus half q dx. So what you have here is what is called the inverse demand function. Inverse, that is the other side. So instead of this is the normal demand function, but when you made the dependent variable to become the independent, when you made the independent variable to now look like it is the dependent variable, and then you made the dependent variable to look like it's the independent variable. Okay, what you have concerning the demand function is that you'll be having an inverse demand function. So what we have, so here, this is the constant, which is telling you that if quantity were 0, the price of this product is going to be 25. Alright, if the quantity of this product were 0, the price will be 25, and so on and so forth. So so with that, I can easily just put let's just follow conventional demand. So we have Px here, the price of commodity X, and then we have, so this place being the quantity demanded of commodity X, other things being equal. So how do we sketch the graph? Now there are possible values that this is now acting as if it were the independent variable, right? Okay, there are possible values that this can take. Since price now looks as if, okay, let me just maybe I shouldn't just use this. Okay, maybe I shouldn't just use this. Let me just kind of, if I should continue with this. Okay, if I continue with this. Anyway, let's just do it this way. So since this is now looking like it's the independent, or since this is like the independent variable in the inverse demand function, and this is the dependent variable, there are possible values that QBS can take that will not make this function to be unsolvable. So when I'm talking about unsolvable, I'm talking about something that will not make this function to become undefined. Now, I don't know if you've done one or two things using your calculator before, and then the result will maybe syntax error or undefined. If there's a calculator like that tells you undefined, or something that you cannot solve for x or something like that. So that is trying to tell you that the equation cannot be solved in that particular with the kind of data that you've input into it. So here, like I said, the possible values of QDX. There's a positive value there is a positive interval of value that QDX can take being the dependent variable, and there's a possible value interval of values that PS can take being the dependent variable in this case. Now the possible values that an independent variable can take that will not make the equation or the model to be undefined, to be unsolvable, it's called the domain. Alright, it's called the domain. Alright, which is telling us the interval of values that the independent variable of a model or function can take that will not make the model unsolvable. Now, the same thing for the dependent variable is actually called the range. So you could have a question that will ask you to find the range and the domain, or the range, the range and the domain, or maybe either of them of a particular model or a function. Alright, so here, now this will now take us to some rules. Let me say, to find the range is not kind of difficult because range is talking about the values that this is taking. And we already know that to get the value that this is taking, you must have known the values that what it can take. Alright, so the values, so that means if, okay, for example, here I said when PS is 0, we could easily get 50, right? So which means that the range depends on the domain. So that's what I'm saying. Once you get the domain, you can get the range. Alright, once you get the domain, once you get the possible values that the independent variable can take, that means automatically you will know, because the dependent variable is a response. Alright, so another name, I think I skipped that. Another name, this is called independent variable. It could also be called stimuli. Okay, it could be called stimuli, it could be called the regressor. Alright, this is the dependent variable. So when you call the independent variable stimuli, something that stimulates, you call the dependent variable response. Alright, you call it response. And when you call this regressor, for those that are into regression and econometrics stuff, when you call this the regressor, you call this the regressand. Okay, regressand. Regressor, regressand. Alright, stimuli, response. Okay, kind of input output, something like that. Alright, so independent variable, dependent variable. So you could actually they could assume different names. Alright. So we have the domain and then the range. What was I even trying to? So once you get the value of the independent variable of the stimuli, obviously you are going to be having a response. Alright, so what is more important for us to get the domain? So there are different rules for getting the domain. Okay, so let's say we have a linear function. In this case now we have a linear model. Why is it linear? This one too is also a linear model. It is linear simply because the highest power of the independent variable here is 1. So nothing is written here, but obviously nothing is written here. This is 1. Alright, so when the highest power of the independent variable is 1, then you'll be having a linear, you have a linear function. Okay, or maybe a linear model or what have you. So the line that you're going to be getting, your graph is going to be a straight line. So if this were 2, for example, then now you're having a quadratic function. So you're having a curve. So that would be like this, that would be like this. Okay, so if this were 3, your curves are not going to be like this again. Alright, maybe something like this, like you have an inflection point or something, and so on and so forth. Okay, I'm not saying that's how it's going to be, but maybe, just maybe. So here we have 1, alright, which is a linear, so we're having a straight line. Alright, so whenever you have a linear function, so let's say you have case 1. Case 1, whenever you have a linear function, so how do you get